Hello and welcome to this video on truth tables. In this video we're going to learn how to build truth tables. There are three reasons why we need to know how to make or build truth tables. First, it's going to help us to evaluate the logical consistency of statements or of propositions. Second, it's going to help us compare the logical consistency of two different propositions. And finally, we're going to use truth tables to determine if arguments are valid, and that will be in section 6.4. So those are the reasons why we're learning how to make truth tables. Okay, so here I have the truth functions on the top, negation, conjunction, disjunction, implication, and biconditional. And remember that those are the truth functions that we derived or we explained in section 6.2. We are going to need those truth function tables, and you need to know those tables basically. It's better if you memorize them, but of course they're also in your book. So we're going to use those truth functions in order to make truth tables. Okay, so there will be a series of steps that we're going to have to take in order to build or make a truth table. We're going to be making truth tables for propositions. Right now we're going to start just with one proposition. So over here I have M and W, as you can see. This is a complex or compound proposition. And the reason why it is a complex or compound proposition is because it's composed of simpler propositions. We have the proposition M and we have the proposition W. Notice, by the way, that I'm calling statements propositions from now on because that's technically the name and logic for them. M, remember, represents a statement or a proposition like, for example, John went to the movies. W also represents a proposition like, for example, John went to work. So remember that these are representing or symbolizing propositions, that they do mean something. And of course the whole thing is a conjunction, so this would say John went to the movies and John went to work, right? M and W. Okay, so let's start by building a truth table for this compound or complex proposition, and let me go through the steps. First of all, we need to determine how many lines the truth table will have. The truth table will always have a certain number of lines. It could be 2 lines, it could be 4 lines, it could be 8 lines, it could be 16. So you see there is an increment there, which is expressed by the formula over here, L equals 2 to the n, where n represents the number of simple propositions. And so that is how we determine how many lines we have. Okay, so let's talk about what counts as a simple proposition. Well, a simple proposition is basically just one unique letter. So M is a simple proposition and W is a simple proposition. So here we have 2 simple propositions, right? A negation with a simple proposition is already complex or compound. So we never count. If we had, for example, say we had tilde M, which would be the negation of M, that would already count as complex. Don't think that that is simple. Not M, the negation of M is already complex. So M is simple and W is simple. Okay, so now that we know what simple propositions are and we know that this one has 2 of them, we plug that into the formula, L equals 2 to the n. Because n here is 2, our number of lines will be L equals 2 squared, right? 2 to the n, and that is 4. So we're going to have 4 lines in this truth table. Okay, so now our next step, so once we've determined how many lines we need, our next step is to plug in the truth values, our initial truth values, which we're going to eventually use to compute our final truth value results. And those results will be under the main operator, which in this case is, we only have one, we have the conjunction. So whatever truth values we end up having under that dot, under the conjunction, will be our final values for this truth table. And these are, of course, truth values. Okay, so we need the initial truth value distribution, and we have 4 lines. And so how do we do that? Okay, we take all the truth values and we begin by splitting them in half. Well, how many truth values are there? When I say all the truth values, what do I mean? Well, we only have 2, right? Propositions can either be true or propositions can be false. So all the truth values are just 2. Okay, so if we take them and split them in half, on the first column, we express that distribution. So remember, we have 4 lines. That means that if we split the truth values in half, we're going to have 2 rows of true and 2 rows of false. So this is what our first column will look like, TTFF, and that is based on this distribution where I'm taking all the truth values and splitting them in half. So this is a 4-line truth table. If this were an 8-line truth table, we would do the same thing. We would take the truth values and split them in half, except instead of having 2 T's and 2 F's, we would have 4 T's and 4 F's, because that would be cutting them in half or splitting them in half with an 8-line truth table, right? So this is the reason why here we only have TT and FF. Okay, and notice also that I've put those under the M, under the first conjunct on the left. What's next? Okay, next we take the TT above. So those are the first, that's the first half, right? The other half is the FF. And we split those in half. Well, again, how many truth values are there? Well, there are 2, right? So that means we're going to have, if we split them in half, we're going to have T here on the right. So this would go under the W, which would be the right conjunct. And over here, we would have F, because what I've done is I've split the TT in half, and TF would be, if you take 2 and split it in half, you'd have 1 of each, right? TF. Okay, we do the same thing with F. We split that in half, and so we have, again, T and then F. And so notice what I've done is I've split it in half. Okay, so now we have our initial distribution. This is what we want in terms of our distribution of truth values. Notice that the last column here is alternating. Notice that it's TF, TF. For all last initial distributions, the truth values will always alternate. So it will always be TF, TF. So if it were an 8-line truth table, it would be TF, 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 TF. Okay, the last initial distribution for the last simple proposition would have those alternating. And if it were 16, you would do the same thing, TF, TF, on and on. Okay, so now what? Okay, this is where we use the truth functions above. We have M and W, and on the first row, we have TT, right? Well, this is where we do our computation, basically. So we know that we're going to use the conjunction table because this is a conjunction, right? So we ask ourselves, okay, what happens when both conjuncts are true? Well, this is expressed over here where P and Q are true, right? Well, when both conjuncts are true, then the whole conjunction is true. So over here on the first row, we're going to write T. And that's because when they're both true, the whole conjunction is true. I'm going to put it in red to express that that's our final truth value here. Okay, we move on to the second row, and we do the same thing. We ask ourselves, okay, what happens when one conjunct is true and the other one is false? Well, again, we're dealing with conjunction, and in this case, we would look at the second row in the conjunction table, right? And that's the case where P is true and Q is false. Well, the whole thing ends up being false, right? Okay, so that would be an F. And again, let me make it in red here. Okay, we go to the third row, or the third line. Remember, these are lines. Lines or rows, I guess you call it either way. Okay, well, that's the case in which the P over here is false and the Q is true. And that is also ends up being, the whole thing ends up being false, right? The whole conjunction ends up being false. So that would be F. Let me make it in red again so that to express that this is our final value. Okay, and the last one is FF. What happens when they're both false? And that's, of course, the last scenario, right, where P is false and Q is false. Well, then the whole thing is still false, right? So we would write an F over here. Okay, let me make that in red so that we have expressed it as our final value. Okay, everything in red is our last value for the whole conjunction here, and that is it. That is the complete truth table for M and W. Okay, let me do another one that's a little bit more complex. And then in the next video, I'll do some that are even more complex. I'll do some 8-line ones, just to show you that the procedure is always the same. It's just a matter of, with the 8 lines and 16-line ones, it's just very tedious. And you will never have to do a 16-line one, by the way. But you should know how to do 8-line ones. And of course, you have to start with the easy ones. You have to start with the 4-line ones. Okay. Let's take this one, which is a little bit more complex than our last one. Remember, that is C or not B. And so, again, remember that these represent propositions. They're symbolized propositions. So C can represent a proposition, and B will represent a proposition. Then we have the negation of B here, right? Okay. C can be something like I eat cereal for breakfast, or I do not eat bread. B would then symbolize I eat bread, right? Because I do not eat bread would be not B. So something like that. Again, anything can be represented here in terms of propositions. Okay, so it is complex or compound already, because we know we have more than one simple proposition. So C is one simple proposition. Remember what I said earlier, B is another simple proposition. And that's it. We also have 2 here. Not B is not a simple proposition. So we only have B as a simple proposition and C as a simple proposition. We only have 2. Well, remember, that means that we have 4 lines, right? Because L equals 2 to the n, L equals 2 squared is 4 lines. Okay, so now we compute the values. Okay, our main operator here is the disjunction there. Notice that we won't be able to compute this unless we figured out what not B is. Remember, we can't do anything here if we don't figure out what the not B is. So that is actually very easy, because we already have the values for B. We have TF, TF, right? So what we have to do is just compute the opposite of those, because remember, with negation, you're always dealing with the opposite. And of course, the table is up here, right? If P is true, not P is false. And if P is false, then not P is true, right? Okay, so all we have to do is fill in the opposite values here. If B is true, then not B is false. Let me do this in blue. Okay, the second line, if B is false, then not B is true. Let me make that blue. And then the third line, if B is true, we already saw that the negation would be false. And then our last line, we have B as false, so the opposite of that would be true. Okay, this is our value under the negation. F, our values actually is more than one. F, T, F, T, right? Which is the opposite of T, F, T, F. Okay, so now when we compute the main operator, when we compute the whole thing, we are computing it with that negation, because that is the final result for the right disjunct. We don't compute it with the T in black over here. For example, for the first line, we compute it with the F, because that's our final truth value evaluation for the right disjunct, right? Okay, so the table that we're looking at here is the disjunction table, of course, P or Q, and here are the truth value scenarios for that. P, if they're both true, if one is true and the other one is false. Okay, so we've already gone over that. So we're going to use that table, and remember the criterion there. Basically, with the disjunction, if at least one is true, the whole thing is true. The only case in which the whole thing is false is when they're both false, right? So keeping that in mind, we could just go down the list and compute everything. T or F, well, that would be T, because at least one is true, right? So let's make that in red to show that that's our final truth value. Okay, T or T, well, that's also true, right? And again, you could look back at the table here. I'm taking this from the table. T or T, or true is true. Okay, F or F, that's the only case in which the whole thing is false, right? So that would be false. Let's make it in red. And then finally, F or T, again, at least one true. That is the third row in our disjunction truth function table up there, and that's of course false. Okay, that is our final evaluation here. It's the one in red, and that is our final truth value evaluation for that compound or complex proposition, C or not B. Okay, so in our next video, I'm going to do ones that are a little bit more difficult, but you just have to practice, and that's what the homework is for. Practice doing them so that